derivatives and integrals of power series. Theorem. Let's suppose that the function fx is given by Maclaurin series like this: a0 plus a1x plus a2x power 2 plus etc. For each x in the interval minus r. So this condition is so important. So this theorem only correct if it's satisfied on an interval. So then the derivative of f will be given by derivative of a0, it's 0, derivative of a1x, it's a1, derivative of a2x power 2, 2a2x, etc. So I will take the derivative term by term. Then, if I write the sigma like this, sigma an x power n, so the derivative of x power n is n times x power n minus 1. So f derivative will be sigma n x power n minus 1 from 1 to infinity or from 0 to infinity. If I write from 0, the first term will be 0 here. So this formula, this is Maclaurin, this sigma is Maclaurin series of the function f derivative x on the interval minus r. And also the integral of the function fx is given by a constant plus the integral of a0, it's a0x, integral of a1x, a1 over 2, x power 2, etc. Now the integral of x power n, it's x power n plus 1 over n plus 1 times an, your constant. So we can write the sigma like this. So this is Maclaurin series of the function integral of fx on the interval minus r. Let's take some exercises. Find Maclaurin series of the function ln 1 plus x. Let's remember the formula 1 over 1 minus x. It's sigma x power n from n equals 0 to infinity. This is on the interval minus 1, 1. Or you can write x absolute value less than 1. Now let's change each x here by minus x. Let's change x by minus x. So we can write 1 over 1 plus x could be written as 1 over 1 minus x. Then write instead of x here minus x, instead of x here minus x, it's sigma minus x power n from 0 to infinity. Also, it could be written as sigma minus 1 power n times x power n from n equals 0 to infinity. Now let's take and this is also correct on the interval. So from here to here, from this function to the sigma, it's correct on the interval minus 1, 1. So let's take the integral of ln of 1 over 1 plus x. So the integral of dx of over 1 plus x equal the integral of each term here. So the integral of sigma minus 1 power n times x power n from n equals 0 to infinity dx. So this could be written as sigma minus 1 power n from 0 to infinity times integral of x power n dx. So it's sigma minus 1 power n times x power n plus 1 over n plus 1 from 0 to infinity. And this is correct on the interval minus 1, 1, if x moves from minus 1 to 1. So the integral of dx over 1 plus x, it's ln 1 plus x plus a constant equal sigma minus 1 power n times x power n plus 1 over n plus 1 from 0 to infinity. Okay, we can write this also. If I give n 0, I will have 1 times x. So let's write x. X, if I give n if I give n 1, I will have uh, minus, so minus x power 2 over 2 plus x power 3 over 3. If n 3, so here negative, and x power x2, x power 3 over 3, and positive because n2. So here fn2, this is fn1, and here fn0. Okay, minus x power 4 over 4 plus x power 5 over 5. Now, if I give x 0, I will find ln1 plus c equal 0, because here each term 0. So ln1 is 0, so the constant c is 0. So now let's write the last formula here, that's ln1 plus x equal x minus x power 2 over 2 plus x power 3 over 3 minus x power 4 over 4 plus x power 5 over 5, etc. This is on the interval minus 1, 1. Okay. Now the second question, find sigma, find 1 minus a half plus 1 over 3, etc. So if we go back the previous formula here, this formula, let's repeat this formula. So we have here ln 1 plus x equal x minus x power 2 over 2 plus x power 3 over 3 minus x power 4 over 4 plus x power 5 over, etc. Let's give x1. If I give x equal 1, so you will have ln 1 plus 1 equal 1 minus 1 over 2 plus 1 over 3 minus 1 over 4 plus 1 over 5, etc. Okay, so the final answer of this addition will be ln 2, because this term here, ln 2. Okay, remember, someone will ask here, there is a mistake in this solution, maybe, because this is correct. I know this formula on the interval minus 1, 1 without 1. So it's opened at 1. How can I give 1? Okay, it's a good question. So let's take this series. Let's study this series. So is it converge or diverge? So let's take this series 1 minus a half plus 1 over 3 minus 1 over 4 plus. So this is sigma, the same as this sigma here, but instead of x1. So I have, this is sigma minus 1 power n over, if I write here n, if I give n 0, it will be positive, so let's write plus 1. Okay, if I give n 0, it will be here, no, it's correct. No, without plus 1. Okay, I give n1. Okay, so the beginning, okay, the beginning is 1, because if I give n1, it must be negative, so let's write plus 1. Okay. If I give n1, I will have this term. This is for n equal 1. Here, n equal 2. If I give n2, so here 3 minus 1 power 3 negative, and down, I will have 2, etc. So now this series converges using alternative series tests. So this one converges using alternative series test. Why? Because if I suppose this as sigma minus 1 power n plus 1 times an. So an satisfies the condition an bigger than 0 or equal 0, and this is approaches to 0 also and decreasing, approaches 0 and decreasing. So these are my three conditions: positive, approaches decreasing, second condition, and approaches 0. So all of them are satisfied because an is 1 over n. So because this theory converges, I can give, so I can close the interval. I can write from minus 1 to 1, closed at 1. Okay. So for this reason, I can give x equal 1. Next exercise, find Maclaurin series of arctangent x. Remember that what is the derivative of arctangent x? Arctangent x derivative is 1 over 1 plus x power 2. So let's think about the Maclaurin series of this function, this one, 1 over 1 plus x power 2. So 1 over 1 plus x power 2 could be written as 1 over 1 minus x power 2. So I can write sigma minus x power 2 power n from 0 to infinity, and this could be written as sigma minus 1 power n times x power 2n from 0 to infinity. So let's take integral of both sides. Integral of dx over 1 plus x power 2. This is arctangent x plus constant equal the integral of this sigma minus 1 power n times x power 2n from 0 to infinity times dx, all of this sigma times dx, is sigma minus 1 power n from 0 to infinity divided by 2n plus 1 times x power 2n plus 1. And remember that this formula here, let's write in 2, for example. So this step from here to here is correct when minus x power 2 absolute value less than 1. This gives me x absolute value power 2 less than 1. So x absolute value less than root 1, so on. So this is correct on the interval minus 1, 1. Okay. Now let's let's find c. Give x 0. So we'll find arctangent 0 plus c equal. If I give x 0 here, let's write this series as in details. If I give n 0, I will have here 1 over 1, so it's 1 times x power 1. If I give n 1, it will be minus 1 over 3, x power 3. Then if I give n 2, it will be here 5, and here plus x power 5 over 5 minus x power 7 over 7 plus x power 9 over 9, etc. So if I give x 0 here, so this will be 0. All of this term here, the right will be 0. So what is arctangent 0? It's 0 because tangent 0 is 0. So finally the constant is 0. So let's write in red the formula of arctangent x. So arctangent x is equal to sigma minus 1 power n divided by 2n plus 1. So odd number down from n0 to infinity times x power 2n plus 1. So we can write this also as x minus x power 3 over 3 plus x power 5 over 5 minus x power 7 over 7 plus x power 9 over 9 minus x power 11 over 11, etc. And this is on the interval minus 1, 1. But at 1 and at minus 1, it could converge also. For example, at 1, if I give x1 here, I will have also a convergence series using alternative series test. Let's see now the next exercise, number 4. Find this sum. To solve this, let's remember the formula of arc tangent x. It was x minus x power 3 over 3 plus x power 5 over 5 minus x power 7 over 7 plus x power 9 over 9, etc. And this is correct on the interval minus 1, 1. And here, to find this term, I need to find this series at 1. At x equal 1, I will have arc tangent 1. It will be 1 minus 1 over 3 plus 1 over 5 minus 1 over 7. Okay, now this series here on the right, plus without stop. So this is sigma minus 1 power n over 2n plus 1 from 0 to infinity. So this is also converges by alternative series test. Alternative series test. Because this is sigma minus 1 power n times an, and the function that an, which is 1 over n plus 1, satisfy the conditions, all the conditions that it's positive and approaches 0 and decreasing. Okay. So from 0 to infinity. So what is arc tangent 1? Arc tangent 1, it's pi over 4. So my answer is pi over 4. Why it's pi over 4? Because tangent pi over 4, it's 1. Okay, next exercise. Find Maclaurin series of 1 over 1 minus x power 3. What is the derivative of 1 over 1 minus x? It's 1 over 1 minus x power 2. What is the derivative of 1 over 1 minus x 2 times? So it's the derivative of 1 over 1 minus x power 2. 1 time. So it's 2. If you calculate this term, it will be, here I will take 1 minus x power minus 2 derivative. So it will be minus 2, the power here, times the derivative of 1 minus x minus 1 times 1 minus x power minus 3. So I have the answer of 1 over 1 minus x, 2 derivatives. It's 2 over 1 minus x power 3. And in fact, we can prove in general that if we take, we don't need this formula now, but it's so famous formula in mathematics that if I take the derivative n times, I will have n factorial over 1 minus x power n plus 1. Okay, now let's go back to our exercise and let's take, remember that the formula of 1 over 1 minus x, it's sigma x power n from 0 to infinity. So let's take the first derivative. By taking the first derivative, 1 over 1 minus x power 2, it's the derivative of sigma x power n from 0 to infinity. It's sigma n x power n minus 1. So this is from 0 to infinity, and we can write from 1 to infinity, because if I give n 0, this term will be 0, the first term. Okay, now let's take also the derivative. So the derivative of 1 over 1 minus x power 2 derivative, which is 2 over 1 minus x power 3, also equal the derivative of this term. Derivative of this term, let's repeat this term, n x power n minus 1, derivative from 1 to infinity, it will be sigma n minus 1 x power n minus 2 from 1 or from 2 to infinity. If I give n1, this term will be 0. So this is 2 over 1 minus x power 3. So the last step now, 1, I will divide by 2 over 1 minus x power 3 equal sigma n minus 1 power over 2 times x power n minus 2 from 2 to infinity. So from the beginning, this formula is correct on the interval minus 1, 1. So all the calculation, all the series on the interval minus 1, 1. So this is on the interval minus 1, 1. So this is the Maclaurin series of 1 over 1 minus x power 3. And it's valid on the interval minus 1, 1. Exercise, find sigma n x power n. So the idea here is to write this sigma n x power n as, if I suppose this is fx from 1 to infinity. So we can write this, let's calculate, but divide by x. Fx divided by x is equal to what? Sigma n x power n minus 1 from 1 to infinity. Now let's take the integral of both sides. Okay, let's use another method. Let's take this is, I can take x outside, sigma n x power n minus 1 from 1 to infinity. So this is x, this is on the interval minus 1, 1. X times, this is the derivative of sigma x power n from 0 to infinity. Then equal x times, this is 1 over 1 minus x derivative. So this is x times 1 over 1 minus x power 2. So the final answer of this sigma is x over 1 minus x power 2. And this is correct on the interval minus 1, 1. On the interval minus 1, 1. The next exercise and last exercise. To calculate this sigma, let's use the last formula which we found, the last exercise. So let's use this sigma, x over 1 minus x power 2. So x over 1 minus x power 2 equal sigma n x power n from 1 to infinity. Let's take the derivatives of both sides. Remember that this formula correct from minus 1 to 1, so I can use the theorem. So the derivative of x over 1 minus x power 2 derivative equal the derivative of n x power n from 1 to infinity. Now the derivative of this term is sigma n power 2, derivative of x power n, x power n, and I have n here, so n power 2 x power n minus 1 from 1 to infinity. Now, I need in the question here n power 2 x power n. So let's product both sides by x. So I have sigma n power 2 x times x power n minus 1 from 1 to infinity. This is equal to sigma n power 2 x power n from 1 to infinity, and this is equal to x times the derivative of this function here. So this is the derivative of x times 1 minus x power minus 2 derivative. So only let's calculate this derivative. So equal, we have x times. I will write big parentheses for these two parentheses, for this parenthesis and this. Derivative of the first, derivative of x is 1 times the second, so 1 minus x power 2 plus x the first times derivative of the second, derivative of this term, we calculated this before, it's 2 over 1 minus x power 3. So we can write here x times, this is minus 2 here, derivative of x1 times this term without change. So here I can write this as 1 over 1 minus x power 2. But I will write power 3 and up 1 minus x plus 2x over 1 minus x power 3. So the last step now, the addition of these two terms. So let's write the final answer here. In red, that sigma n power 2 x power n from 1 to infinity equal the addition of these two terms here is 1 plus x times x, so x times 1 plus x over 1 minus x power 3. This is correct on the interval minus 1, 1, because from the beginning, this formula here, this step, which I am using here, even this formula from the last exercise, it's on the interval minus 1, 1. Now, the second part of the exercise, find 1 over 2 plus 4 over 9, 4 plus 9 over 8. So remark that these numbers, 1, 4, 9, 16, 25, 36, it's always something of the form n power 2. 1 power 2, 2 power 2, 3 power 2, 4 power 2, 5 power 2, 6 power 2, etc. Divided by, in green, this is 2, 4, 8, 16, 30. So 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6. So this is 2 power n. So here, for example, here, this fraction, 6 power, so this fraction is 6 power 2 over 2 power 6. So let's give here x a half. So if I give x equal a half, and a half is on the interval minus 1, 1, so I can give x a half. So I have sigma n power 2 divided by 2 power n from 1 to infinity. This is my sigma here. So this is sigma n power 2 over 2 power n from 1 to infinity. This is equal to, instead of x a half times 1 plus a half divided by 1 minus a half power 3. So this is a half times 3 over 2 divided by 1 over 8. So it's 3 over 4 divided by 1 over 8. So the answer is 6. So this is the final answer of this addition. This addition is equal to